Hi class, welcome back to Computational Tools. Today we'll be starting our unit on MATLAB. So MATLAB stands for Matrix Laboratory, and so it's designed for manipulating matrices. And what we're looking at here is MATLAB's GUI or graphical user interface. So I'd like to give you first a little tour of the graphical user interface. So up at the top, you see that there are several different tabs. There's a home tab where you can start a new script. And so what I've done is I've saved these early tutorial files as .m files, so .matlab files. And these .m files are just the traditional MATLAB scripts. And so the idea is you'll be able to run through these and save your scripts and upload them in the same format back to Moodle. And a live script is something that it has the extension .mlx, and we'll work with those a little later in the semester. They are a bit more interactive. Their visualization is a lot nicer than the .ms. And so also you have a plot ribbon, an apps ribbon, an editor ribbon. So we'll be working a lot with the editor ribbon while we have our script open. Okay, and some other pieces here. So this window in the center is your script window. And if you run a line of script, you send it down to the command window. So just like we had that function line in Excel, you could see this function line down at the bottom in the command window. So you're sending your function down there. Now, up above that script window, we have our directory. So this is showing you which folder or where you're working out of on your computer. So for example, I'm working out of Dropbox, and I have many folders and subfolders in there, one devoted to GCC and my courses in this class, in this semester, and this unit. And so for example, let us just begin by saving our script. So if I go to the save disk, save as, and put it into the directory you want to save it in, and I'm going to save it with my last name and first initial. Now you can see that it's renamed my script, and it has saved it into our current folder. So you can see though, if I go back to Spring 20, you can see all my different folders in Spring 20. So I'm going to open up MATLAB again. So this is the directory I'm working out of. And the idea with these tutorials is, yes, you can work through them without watching these videos, just going through the tutorials on your own. But I think it's always helpful if you get stuck and want to see how something is supposed to look, to go back to these videos and be able to take a look at me running through the same tutorial. And on the right, you'll also see your workspace. So in your workspace, you're going to be able to see saved variables, arrays, data sets, functions. And we'll get into functions a little later in the semester because there's a few different types of functions, and where they operate from is a bit different. So let's just get started on this tutorial. And all these tutorials are adapted from this Intro to MATLAB, modified from Shapra 2018. And so we've already started with saving, and just remember to upload this by the deadline. And I gave you a link for the free version, for the free trial version of MATLAB. It's only a 30-day trial, so please try to wait till April 15th to install it, since your project for MATLAB will be due on May 15th. Okay, so Each MATLAB command line can operate as a calculator. So let's try to just use some of these basic calculator commands utilizing their operators. And so when you type into your script and you want to send what you typed down to the command line to run that line, you could either click the run button up at the top, or if you have a Mac, you can hit Command Enter. If you have a PC, you can hit Control Enter. So let's just start by doing 15 plus 40. And I have a Mac, so I'm going to do Command Enter. And you can see down in the command window below, we got our output, and it says answer equals 55. So the variable by default assigned to this is answer. So this value is saved in the workspace as answer. So just like in a calculator, if you try to type then answer plus 25, then it adds 25 to your answer. So 55 plus 25 is 80. But now you could see that answer, still stored in your workspace, has been overridden by the value 80. Now let's try assigning values to scalar variables. So let's try typing a equals 4. Okay, so you can see a equals 4 shows up below in your command window, and a is also stored in your workspace as 4. So what you're seeing in the command window below is that the assignment echo prints to confirm what you have done. Okay, so you typed a equals 4, the command window echo printed a equals 4. So let's say you want to suppress that echo print. In order to do that, you terminate your line of code with a semicolon. So say we typed capital A equals 6, and we terminated it with a semicolon. I'm going to send that below. And you see that it did not show up in the command window, but it did show up in the workspace. Okay, so next, several commands can be typed on the same line by separating them with commas or semicolons. So if you separate them with commas, they will be displayed. And if you separate them with semicolons, they will not. And so let's try to type out several variables in one line of code. So we'll do lowercase a equals 4, comma, capital A equals 6, semicolon, and x equals 1, comma. Oh, sorry, I typed in a colon. There we go, semicolon. Okay, and so you can see in the command window below, we got x equals 1 out and lowercase a equals 4, but capital A equals 6 was suppressed. Yet all those variables have been stored in your workspace. So one note, since I made that oopsie before, MATLAB will yell at you when there's an error. It'll say, error, you did something wrong. And so it told me I used an operator, the equal operator, incorrectly because I had typed in a colon in that line. All right, so it lets you know when you have made a mistake. And if you've noticed kind of my funky coloring back here, if you go to preferences under MATLAB ribbon up at top, you can play with your colors and fonts and all that stuff. So feel free to play with that on your own time. Okay, so you may have noticed that MATLAB is case sensitive. So the variable capital A does not equal the variable lowercase a. So let's type A, capital A, and send it to the command window, followed by lowercase a. Okay, so you could see when I type capital A, 6 reported back, echoed back, and when I type lowercase a, MATLAB printed 4. Okay, so it's just reprinting what you have stored in your workspace. Now, MATLAB can also recognize complex values, and they can be assigned to variables. So it automatically recognizes the imaginary number I okay, as the square root of -1. So let's just type in x is equal to 2 times I times 4. Okay, and so you could see that it has stored it as 8I, 2 times 4 times I. And so x is now saved in your workspace. So MATLAB also allows j to be used to represent the unit imaginary number for input. However, it'll always use I for display purposes. So even if you type x equals 2 times j times 4, that will still be stored as 8I. Okay, so it recognizes both I and j as the unit imaginary number. It also recognizes pi as pi. So let's type pi. Okay, and you can see it shows pi to 4 decimal places, 3.1416. And if you desire additional precision, we could change MATLAB's default format. So let's format long. Okay, so format function long, the format command in long. And then let's retype pi. Okay, and so now you can see that there are 15 digits. Okay, so 14 decimals. Now we can reformat back to short by typing format short. That is MATLAB's default, but this is a summary here of the format commands. So we have short, long, short E, which is floating point with 5 digits, long E, which is floating point with 15 digits. We have short G, which is best of fixed or floating point with 5 digits. We have long G. We have engineering format, so those are multiples of the power of 3. And also bank format, fixed dollars and cents. So why don't you pause this for a moment and take a couple minutes to try to apply some of the above formats to pi just to get a feel for it. Okay, so an array is a collection of values that are represented by a single variable name. One-dimensional arrays are called vectors, and two-dimensional arrays are called matrices. Scalars can be thought of as matrices with one row and one column. So, brackets are used to enter arrays in MATLAB. So let's try entering an array. So we're going to type in A equals open bracket. And now notice that you separate the numerics in the array by a space. So 1 plus 2 plus 3, 1 space 2 space 3 space 4 space 5, close the bracket up, send it down. All right, so notice by default it comes out as a single row, right? A multiple columns, single row. So now notice that this overrided the previous assignment of A equals 4 in your workspace. And row vectors in practice are rarely used to solve mathematical problems. So when we talk about vectors, we're usually referring to column vectors, which are more commonly used. So a column vector can be entered in several ways. So one way you can input this as a column vector is by separating each number by a semicolon. So B equals open bracket 2 semicolon 4 semicolon 6 semicolon 8 semicolon 10. Okay, so that should send out a column vector. Okay, so you can see that in the command window below that B is now a column vector. Another way you can enter a column vector is by placing each entry on its own line. So now let's try B equals open bracket 2, enter 4, enter 6, enter 8, enter 10. And we're going to close it up and send it down. So same thing. And so you notice MATLAB automatically tabbed over your entries. Okay, so automatically recognized that you were continuing whatever line you're working on. For me, it was line 130 in the subsequent lines for that command. So column vectors can also be generated by transposing a row vector using the single quote operator. Okay, so B equals, or the apostrophe, there we are, 2 space 4 space 6 space 8 space 10. So that would be a row vector, and to make it a column, we just put the apostrophe and we can send it, and you can see that it is saved once again as a column vector. So now you've seen 3 different ways of generating column vectors in MATLAB. And now let's look at matrices. So a matrix of values can be assigned as follows. So let's name this matrix capital A. And I'm going to have my open bracket. And so we'll do 1 space, 2 space, 3. So we have just filled in 1 row, and then putting in the semicolon is saying, okay, now we're going to move down to the row below, and we'll have 4 space 5 space 6 semicolon. So we're going down now to the row below, and that's going to be 7, 8, 9. Close the bracket up. So now you can see that we have just generated a 3 by 3 matrix by setting up 1 row at a time. Additionally, the enter key, also known as the carriage return, can be used to separate the rows. So let's try to generate this matrix another way. So A equals, open bracket, 1 space 2 space 3, so carriage return or enter, and then the next row is going to be 4 space 5 space 6, enter, 7 space 8 space 9, close the bracket up, and we just generated that matrix once again. Okay. And now let's try our third technique for generating matrices. And so this time we are going to concatenate, in other words, join the vectors representing each column. So capital A is equal to, so now I'm going to do a series, I'm going to stick columns together. So open bracket, now we're going to do a single column that's going to be 1 space 4 space 7. So we're going down column by column. So this is our first column. So we're going to tell MATLAB that this is a column and not a row. So put our apostrophes or a prime, whatever you'd like to refer to it. And then 2 space 5 space 8, that's our second column. Transpose it. And then 3 space 6 space 9, close the bracket up, transpose it, close the bracket. Okay, so now we made a column by column matrix, and it comes out exactly the same. So at any point in a session that you have open in MATLAB, you can list all current variables by entering the who command. So let's try out who. So if we type who into our script and send it down to the command line, okay, we get out all the variables that are in our workspace. You see capital A, lowercase a, answer, lowercase b, and lowercase x. So those are all variables that are stored in our current workspace. So this workspace is only applicable to the script that you currently have opened. Global is something else entirely, and that can be applied to several different scripts, but we'll work with local versus global variables a little later in the semester. I just want you to realize that they both exist and they operate differently in MATLAB. And so one more thing is, for these tutorials, make sure you're typing in everything in your script and then saving it, because that's what I want to see uploaded to Moodle. Okay, let's try again. So don't type it directly in the command window. Type your commands in the script and save it so I can see your work. All right, so now type whose, and this will show more detail. So it'll tell you the types of variables. So it'll give you the name, it'll give you the size, it'll give you the bytes, and it'll give you the class. Okay, so you notice that A is a 3 by 3 matrix, and capital A. Lowercase a is 1 by 5, and you'll see that lowercase b is 5 by 1. So notice 1 by 5, so that is 1 row by 5 columns. 5 by 1 for B, you'll notice, is 5 columns by 1 row. So B is stored in your workspace with semicolons. And then lastly, notice X. And its attributes are that it's a complex variable, right? Because it includes I. Next, the subscript notation can be used to access an individual element of an array. For example, now let's type B, and we want to see the 4th element. So that's what the parentheses are used for. So you're referencing B, and you're picking out the 4th element of the vector. So you notice the 4th element of vector B is 8. So it's going to be 1, 2, 3, 4 is 8. Okay, if you count over. But the thing is, so it's pretty straightforward for an array, but what about a matrix? So, or for, it's pretty straightforward for a vector, but how about an array or a matrix? So for an array, looking at the syntax, A of m and n selects the element in the mth row and the nth column. So m represents the row and n represents the column. So let's try typing A 2, 3. And we get 6 back. So if you need a refresher of what A looks like, you can type in A below. Okay, so our output was 6. And you'll notice that in the 2nd row and in the 3rd column, indeed, our number is 6. MATLAB has several built-in functions that can be used to create matrices. For example, the ones and zeros function create vectors or matrices filled with ones and zeros, respectively. Both have 2 arguments, the first for the number of rows and the second for the number of columns. For example, let's create a 2 by 3 matrix of zeros. So let's call that E equals zeros, 2, 3. Okay, so you notice that now the output for E is a matrix with 2 rows and 3 columns, all filled with zeros. And the ones function operates similarly. So let's define U as a matrix of ones that's going to be 1 row and 3 columns. So you can see that it's a row vector of ones. Now, let's actually look at what this colon operator does, the thing that I accidentally typed on earlier. So the colon operator is a powerful tool for creating and manipulating arrays. If a colon is used to separate 2 numbers, MATLAB generates the numbers between them using an increment of 1. So type in t is equal to 1 to 5. So you'll notice that the output for t is a single row vector that is going to be 5 columns, and it's going to count up by 1 by default. So it starts at 1 and it ends at 5, and it counts up by increments of 1. So if colons are used to separate 3 numbers, MATLAB generates the numbers between the first and third numbers using an increment equal to the second number. So let's say we want to specify by. So which increment are you counting up by? So t is going to be equal to 1. So we're going to start at 1. We're going to go by increments of 0.5, and we're going to end colon at 3. Okay, and so t is going to be 1, 1.5, 2, 2.5, 3. And you can also use negative increments in MATLAB. So let's say t is now equal to 10 by minus 1, so we're counting down from 10 to 5. Okay? Aside from creating series of numbers, the colon can be used as a wildcard to select the individual rows and columns of a matrix. When a colon is used in place of a specific subscript, the colon represents the entire row or column. For example, the second row of the matrix A can be selected as follows. So we're looking at matrix A, and we're going to select everything in the second row, so all columns. So to represent all columns, we use the colon. And once again, let's remind ourselves what A looks like. And so you can see the output was 4, 5, 6, which was in fact our second row of matrix A. We can also use the colon notation to selectively extract a series of elements from within an array. For example, based on the previous definition of the vector t, let's first remind ourselves of what t was. Okay, so we can see our vector t. And now let's type t from 2 to 4. So what happens is we selected the second through fourth elements of t. So we got back out 9, 8, 7. So the second to fourth elements. The linspace or linear space and log space or logarithmic space functions provide other handy tools to generate vectors of spaced points. So the linspace function generates a row vector of equally spaced points. So it has the syntax, your starting point, ending point, and the numbers, which generates the n being the number of points in between your start and your end. So let's try linspace starting at 0, ending at 1, but it's going to be n elements long, so 6 elements long. Okay, so we can see we started at 0, we ended at 1, and it's 1, 2, 3, 4, 5, 6 elements long. So if the n is omitted, the function automatically generates 100 points. N equals 100 is the default length. The log space function generates a row vector that is logarithmically equally spaced. It has the form log space, and you're going to go from start to end, and there's going to be n elements, and it's going to generate logarithmically equally spaced points between 10 to the first and 10 squared. So for example, let us do -1 to 2, and there's going to be 4. Okay, so we started at 10 to the -1, which is 0.1, and we ended at 10 squared, which is 100, and so then we filled in, it's going to be length of 4 elements. So if the n is omitted, then how many points are automatically generated by the log space function? So take a pause here, try this on your own, type in your answer, and I'm not going to do this part with you. Aside from numbers, alphanumeric information or character strings can be represented by enclosing the strings within single quotation marks. So for example, let's type F is equal to miles. Okay, so with just like in Excel, if in MATLAB, if you put a text string or a character string within single quotes, in Excel it was regular quotes, you're telling MATLAB that this is a character string and to read it as exactly as is. So F is equal to miles in single quotes, and S is equal to Davis in single quotes. Let's suppress that. So we're suppressing both with semicolons. So you see that nothing gets sent to the command window. However, F and S are both saved in our workspace. You notice how they have C and H for characters next to them. All right, and they're also in the single quotes. So each character in a string is one element in an array. Thus, we can concatenate the strings. So if we say x is equal to f space s, okay, so we're making a row vector, you can see that we get Miles Davis as the output. Note that very long lines can be continued by placing ellipses at the end of the line to be continued. So, for example, a row vector could be entered as, so let's type lowercase a is equal to 1 space 2 space 3 space 4 space 5. And so we're going to do the ellipses, the 3 dots. It's going to tell MATLAB, oh, this line of code is continued onto the next line. And so you see that MATLAB default tabs it over. And so you have an indent. And then so you type 6 plus 7, or 6 space 7 space 8, close the bracket up, and then let's run both lines. And you can still see that A comes back out in your command window as a single row, okay, a row vector. So, however, you cannot use an ellipses within single quotes to continue a string. To enter a string that extends beyond a single line, you have to piece together short strings. So let's try one. So we're going to name this string quote. So quote equals open brackets. And so we have to have our single quote inside it to tell MATLAB that this is going to be a character string. So any fool can make a rule, comma, end single quote. Okay, so that is in itself a character string, but now we're going to use an ellipses, so the 3 dots. And so MATLAB knows that that character string is going to continue on to the next line, but then we also have to put that itself in its own single quotes, because if you contain the ellipses within the quotes, MATLAB will interpret that as part of the character string. So, and any fool will mind it. Okay, so now we have our single quote, close the bracket up. All right, so that is completed. We'll send it down to the command window, and you'll notice that MATLAB recognized the ellipses and continued on. So if you put a little space before the and after the single parentheses, that'll adjust for the spacing issue. Now, what you're seeing here is a table that shows some useful string functions. So, for example, n equals length of the string. So the function length will give you the number of characters n in a string s. So then string comparison, strcmp, compares two strings. So you have to input which strings you're comparing. And the output, B, is either going to be an output of 1, which is true if they are equal, or 0, which is false if they are not equal. You could do a string to number conversion, or you could do a number to string conversion. You can replace characters in a string with different characters. You can return the starting indices of any occurrences of the string, some string of interest in a reference string. And you can also convert a string to uppercase or to lowercase. So let's try out some of the string functions. So let's type out x1 is equal to Canada. Okay, so that is a string since it's in single quotes. X2 is equal to Mexico, also in single quotes. And notice how we're suppressing each of these with a semicolon. X3 is equal to USA. X4 is going to be 2010 in single quotes. And X5 is going to be 810, no quotes. So all those are suppressed, but you notice that all were sent to your workspace. So let's do a string comparison, strcmp, between x2 and Mexico, typed out as a character string. And you see that you got a logical 1 or a logical true back because we defined x2 as Mexico, so x2 is in fact equivalent to the character string Mexico. Now, let's do a string to number conversion for x4, which you noticed was a character string of 2010. So yes, you can have numerics in a character string, but MATLAB is going to interpret them as characters, as you'll notice in the workspace next to x4 right now, 2010's in single quotes, and ch is next to it for characters. So let's do a string to number for x4. Okay, so now you got 2010 out, but you notice that x4 was not overridden in your workspace. So all you did is you just converted it to a numeric, but you didn't save it in your workspace because you didn't redefine the variable. So now let's do number to string for x5, because x5 is saved in your workspace as a numeric 810. Okay, and so now you can see it output itself in single quotes as a character string. And once again, it did not override itself in the workspace because you did not assign it to a variable. So if you want to display strings in multiple lines, use the sprint function and insert the two character sequence \n between the strings. So for example, let's type out the function display sprint f, okay? So that's going to be our format, and we'll say, yo, Steve, so let me find my \n, okay, so what we're doing is we're going to display this in multiple lines by using the \n, single quote, and let's close it up. Okay, and so you can see that it displayed those character strings on multiple lines in your command window. Operations with scalar quantities are handled in a straightforward manner in MATLAB, similar to other computer languages. So, of course, the common operators in order of priority are going to be the caret is exponentiation, right? So that's the first priority in MATLAB. Then negation is going to be the minus sign. So that is not plus or minus a number, that is negation. Okay, so the negation is second in priority, and then multiplication and division, then left division, and then finally addition and subtraction. So let's try out some of these operators. And so let's do 2 pi. Okay, comes out exactly as you'd expect. And let's try, say, y is equal to pi over 4. And so you can see that comes out in your workspace. And also y to the 2.45. All right. So results of calculations can be assigned to a variable, as in the next to last example, or simply displayed, as in the last example. As with other computer calculations, the priority order can be overridden with parentheses. For example, because exponentiation has higher priority than negation, the following result would be obtained. So let's try out y is equal to -4 to the second. Okay, and so you notice that order of priority, 4 was squared first, and then it was negated. So to override that, you can use the parentheses. So let's say we want 4 to be negated first. That would be y is equal to -4 to the second. So that will give you +16. So the moral here, when in doubt, use parentheses. So within each precedence level, operators can have equal precedence and are evaluated from left to right. Right, so let's try out a couple of these. Actually, you try these out, pause it, you try these out, and then describe to me what is happening in each of the above cases. So type out what is happening. So one potentially confusing operation is negation. That is, when a minus sign is employed with a single argument to indicate a sign change. So for example, 2 times minus 4. Right, so we get minus 8. The minus 4 is treated as a number. And this might be unclear, so you can use parentheses to clarify the operation. So it's still going to operate the same way, but it's just to make it clearer to yourself. And so then if you do 2 to the minus 4, try that one out. And again, minus 4 is treated as a number. And MATLAB and its toolboxes have a rich collection of built-in functions. You can use online help to find out more about them. For example, if you want to learn about the log function, we can type in help log and send it down to the command window. And so it tells you that in MATLAB, log is natural logarithm. And so it also tells you, well, okay, so if you want to do log base 10, that'd be log 10. Log base 2 would be log 2. And you can click on these to find out more information. And if you want a list of all elementary functions, you can type help L functions. So now you can see all the different elementary functions in MATLAB. Okay, so we have the trigonometric, the exponential, the complex, and the rounding and remainder functions. So one of the important properties of MATLAB's built-in functions is that they will operate directly on vector and matrix quantities. So for example, try log A. Okay, and so that applied the log to each element of the matrix. So you tell me, type in which logarithmic base has been implied. And keep in mind, when you're typing in comments, you need to proceed with a percent symbol. So to comment in MATLAB, you use the percent symbol. So any line that you're writing as a comment, you have to start with that symbol, or else MATLAB will interpret what you've written as a line of code that it'll try to run, and then you'll run into errors that way. So you will see that the natural log function, So you will see that the natural log function is applied in array style, element by element, to the matrix A. Most functions, such as square root, absolute value, sine, arc cosine, hyperbolic tan, and exponential, operate in array fashion. Certain functions, such as exponential and square root, have matrix definitions also. MATLAB will evaluate the matrix version when the letter M is appended to the function name. So try square root MA. Okay. And you'll notice that there are complex solutions. So type in help square root M to find out why that is. And there are also several functions for rounding. And for this part where you're typing help square root M to find out, I want you to type in as a comment. So start with a percent symbol on your line here and tell me what is happening. Now there are several functions for rounding. For example, suppose that we enter vector E is equal to, capital E equals open bracket minus 1.6 space minus 1.5 space minus 1.4 space 1.4 space 1.5 space 1.6 close it and suppress. Okay, and you can see that E is now in your workspace, capital E. The round function rounds the elements of E to the nearest integers. So now try out round E. So type out E. Let's just see what it looks like. Look at it in your command window. And now type round E. Okay? And so you can see that they were rounded to the nearest integers. And so anything that was above a decimal of 0.5 is rounded up. Anything below is rounded down. And you could change that, how rounding is, how you round in MATLAB using the floor and ceiling functions. So let's try ceiling E. So ceiling always rounds up. Now try floor E, and floor always rounds down. There are also several functions that perform special actions on the elements of matrices and arrays. For example, the sum function returns the sum of the elements. So let's generate vector f is equal to 3, 5, 4, 6, 1. Suppress it. And now let's sum up each element of f. Okay, and so the output is 3 plus 5 plus 4 plus 6 plus 1 is equal to 19. In a similar way, it should be pretty obvious what's happening with the following commands. So I want you to go through the following commands and as a comment, describe what is happening. All right, so that is it with our first MATLAB tutorial, and I will see you next time.